Faithfully delivering value, exploring great books worldwide. Hi, this is Sally's Book Club. Today's featured book is Journey into the Ant Realm, published in 1995 by two sociobiologists, Edward O. Wilson and Bert Holdobler. Back in 1990, they co-authored an encyclopedic work, literally thicker than a dictionary. What's remarkable is this scholarly work actually won the Pulitzer Prize. This wasn't Wilson's first Pulitzer. His Unhuman Nature also claimed the honor. Wilson mastered both academic writing and popular science communication. A naturalist since childhood who could catch flies barehanded, his writing radiates love for nature, blending accessibility with profound insight. Time magazine named him among America's 25 most influential people in 1996. As National Academy member, Wilson pioneered sociobiology through ant studies. What makes ants so fascinating to these scientists? They adapted their technical work into accessible science writing. Journey into the Ant Realm gradually unveils these creatures' wonders. The book answers two key questions: how ants live and how they organize their societies. We've all encountered these recognizable insects. As the book notes, the first creature climbing your shoulder might be an ant. When observing nature's small wonders, ants will dominate your count. To be precise, total domination. Though similar in appearance with gradual emphasis, ants aren't monoliths. They're a diverse group with over 15,000 species. Social structure defines ants, forming the elite trio with termites and bees through sophisticated caste systems. Queens reign over reproduction. Workers live up to their name, maintaining colonies, with some species evolving specialized soldier castes. This division of labor drives their phenomenal success. Ants dominate every continent except Antarctica, numbering up to 10 quintillion individuals. Just how immense is that number? At 1 to 5 micrograms per worker, their collective mass rivals humanity's total weight. They're ecosystem engineers, wielding immense ecological influence. Ant extinction would collapse pollination systems and food chains. Soil ecosystems would lose vital engineers and decomposers. Countless ecological networks would unravel catastrophically. In warm climates, ant colonies emerge everywhere. Crouch down and witness their bustling microcosm. What drives this ceaseless activity? Excavators move earth particles, outperforming earthworms in soil turnover. Sanitation crews dispose waste while foragers scout beyond the nest. Territories sustain colonies but confine their reach. Survival demands relentless resource harvesting within these boundaries. Despite workers' efforts, colonies often barely meet nutritional needs, sometimes facing severe shortages. Colonies constantly defend against solitary insects, raids, and theft. Harsh environments forged ants' survival-driven dietary adaptability. They systematically hoard every edible resource within their territory. Insect carcasses provide protein-rich nutrition for developing larvae. Rather than hunting live prey, ants evolved as efficient carrion collectors. Specialists like bullet ants, reaching 2.5 centimeters, actively hunt prey. Their venomous sting delivers pain comparable to gunshot wounds. These capable predators can subdue small vertebrates alone. Harvester ants expertly collect and categorize plant seeds. Their seed collection efficiency approaches 100% for preferred species. Fortunately, stored seeds sometimes sprout, making ants accidental farmers. Some species farm aphids for their sugar-rich excretions. This honeydew is essentially nutrient-dense insect waste. Ants possess specialized crop stomachs for communal food storage. They regurgitate stored nutrients to feed nestmates when needed. Most species process food into liquid form for crop storage. This biological preservation prevents food spoilage. Some colonies designate living storage units among workers. Patrolling workers vigorously defend their territory's resources. In reality, they show no hesitation in employing brute force. The authors assert ants are nature's most belligerent warmongers. Their foreign policy, perpetual territorial expansion through annihilation. Given nuclear capability, ants would obliterate Earth within days. Their biological arsenal remains formidably diverse. Mandibles range from razor-sharp blades to hydraulic pincers. Each species evolves combat tools matching ecological niches. Abdomens house venomous stingers and species like fire ants. Some deploy formic acid sprays to corrode adversaries' organs. Overwhelming numbers compensate for individual vulnerability. Specialized soldier ants decapitate foes with biomechanical precision. Fieldwork proves lethally hazardous daily. Survival demands inverted age-based roles compared to humans. Elder ants become expendable scouts shielding younger generations. This reversed mortality strategy challenges human conventions. Seasonal nuptial flights mark colonial reproduction events. Colonies nurture winged royalty for genetic dissemination. These elates represent the colony's evolutionary future. Mating occurs midair during spectacular, swarming events. Host population queens shed wings to establish new dynasties. Ants typically maintain fixed mating locations through generations. Males arrive first, forming swirling aerial congregations. Females join these sky dances for brief, mid-air couplings. These ancient mating grounds may serve centuries of colonies. Old Doubler's Arizona swamp discovery revealed astonishing behavior. A featureless tennis court-sized area teemed with harvester ants. From dusk till dark, winged queens continuously arrived and departed. This reproductive frenzy persisted through multiple daylight cycles. Annual July observations confirmed enduring biological tradition. The site functions like evolutionary theater for ant courtship. Precision navigation to ancestral grounds remains scientific mystery. Newly mated queens face solitary foundation challenges. Elates sever their wings in irreversible biological commitment. Emergency shelter seeking becomes immediate survival priority. Abandoned burrows or self-excavated tunnels become provisional nurseries. The queen enters monastic isolation within her sealed chamber. Egg to larva transformation spans critical 10 to 15-day window. Nutritional crisis begins with first brood demands. Queens catabolize flight muscles into larval nutrition. This self-cannibalization sustains initial brood development. Starvation pressures force brutal brood culling decisions. First-generation workers emerge undersized but functional. Critical 8-week maturation period precedes workforce activation. Initial workers commence tunnel expansion and foraging duties. The queen is typically exhausted by this stage. The colony's hardship ends when first workers emerge. From nuptial flights to colony founding, nearly all queens perish. Less than 1% of owlets survive to establish colonies. Foraging, defense, and reproduction define ant existence. This evolutionary rhythm has persisted for 100 million years. Instantaneous collective mobilization defines ant societies. How do these tiny creatures achieve such coordination? Olfactory supremacy forms their communication foundation. Ants perceive chemical gradients humans can't detect. They navigate chemical landscapes through pheromone trails. This biochemical language contains 10 to 20 distinct words. Alarm pheromones trigger immediate defensive responses. Colony-specific odor profiles prevent infiltration. Royal pheromones suppress worker reproduction capabilities. Distress signals summon reinforcements within seconds. Scent trails guide nest mates to food sources efficiently. Olfactory coding permeates every social interaction. Even death recognition relies on chemical decomposition cues. Spraying corpse chemicals on live ants triggers immediate disposal behavior from nestmates. Chemical identity overrides biological vitality in ant social protocols. Pheromones don't command, they trigger hardwired genetic responses. Instinctive reaction thresholds govern all ant behaviors. Queens function as reproductive organs, not military commanders. Self-organization principles drive colony-level coordination. Microscopic warfare displays macroscopic strategic patterns. Numerically superior forces systematically compress adversaries. Individual ants lack battlefield situational awareness. Decentralized decision-making replaces centralized command. Local encounter rates determine individual movement decisions. Majority presence signals advance opportunities. Minority status triggers defensive withdrawal protocols. Simple individual rules generate complex collective behaviors. Self-organization transforms local actions into global strategies. Each ant functions as autonomous sensor and actuator. Distributed computation emerges through mass interaction. The colony operates as macroscopic superorganism. Each ant functions as a living cell of the superorganism, its core pulsating underground. It probes the world through antenna-tipped appendages, ready to strike or retreat. Army ants demonstrate extreme social scaling with colonies reaching 20 million individuals. These mobile predators conduct daylight raids, overwhelming arthropods and small vertebrates. Nightly bivouacs form living fortresses using interlocked worker bodies. Their military precision inspired fictional man-eating ant depictions. Actual ecological impact focuses on invertebrate prey, not large mammals. Entire colonies weigh less than an average human child. Leafcutter ants develop sophisticated fungal agriculture systems. Their agricultural practices predate human farming by millions of years. Worker polymorphism creates 500-fold size differences within colonies. Megacolonies construct underground cities housing 8 million ants. Brazilian research documented 44-ton excavated soil complexes. Scaled to human size, their engineering rivals ancient megaprojects. This architectural marvel emerges through decentralized cooperation. Ant societies host symbiotic beetles, crickets, and mites. These intruders seek comfortable microclimates, defenseless brood, or nutritious hemolymph. They mimic colony odor codes to bypass security systems, as Wilson described, biological hackers disabling security protocols. Ant societies lack adaptive immunity against such evolutionary parasites. Humanity and ants both leverage sociality for ecological dominance. Ant evolution sacrificed individuality for collective success. Their 100 million year symbiosis with ecosystems contrasts human disruption. Ant extinction would collapse ecosystems. Human impact destabilizes biospheres. Anthropocene disturbances accelerate climate shifts and extinction rates. Achieving ecological harmony remains humanity's evolutionary challenge. Ant survival strategies offer lessons in sustainable coexistence. This concludes our exploration of Journey into the Ant Realm. Find episode notes below. Until our next literary adventure.